Hello guys, hope you're doing well, and as always, if you are new to my channel, I would request you to subscribe to my channel so that you shall be able to watch all my latest engineering videos. Thank you. All right, so today we are basically going to continue our new series for the statics concept builder questions, and this is part number 2. Okay, so the questions at our hand today that we have selected are basically, if you look at it, you have got A, B, C, D, E, F, six different types of questions. Okay, so these questions are related from different chapters. Okay, so if you look at it, the first question that we have over here is basically define a two force member and also draw its sketch. Okay, for this question, we have to define a two force member and we have to basically sketch it basically in a simple sketch showing the various kinds of forces that will be acting on this two force member. Okay, so if you look at it over here, basically for specifically speaking for a two force member, we can easily define it over here is that this is all members irrespective of the shapes and size when subjected to forces acting only at basically two distinctive points of the members will be strictly called as two force members. Okay, so if you look at it, the conditions for the two force members are the resultant forces acting at 2 points will be same in magnitude but opposite in direction to avoid translation. The two resultant forces must be collinear to each other to avoid rotation for the and moments. The collinear line of action of the forces will be straight line joining 2 points. There will be forces and the 2 points where all the forces were initially acting. Okay, so if you look at it over here, basically this L-shaped bar is basically acting as a two force member. Okay, if you look at it, this curvilinear rod will also be acting as a two force member, and if you basically simplify it further, so this curvilinear bar could be treated in this way, and these two forces Fa and Fb, which have the same magnitude but and they are collinear in basically acting collinearly, and their angle is basically 180 degrees apart. So we can call this and they have the same magnitude F and F, so we can call this curvilinear member or a rod as a two force member. So they basically this is how you would define a two force member. Okay, so we have also shown you the sketch of it. Okay, second is define supports and their use. Mention the name of at least four different supports. Okay, so we have to tell what really is a support is. Okay, and their use. So if you look at it over here, and if we go here, and if we go here, and okay, so if you look at it, this is the chapter for supports. Okay, supports are basically being applied for and used by all structural members in order to basically they are being placed in all structural members in order to they add to the stability of the member, and also they avoid and resist the translation and rotation generated because of the external loading on these members. So you can define supports as this, how you easily a definition of the supports. And if you look at it, this is a roller support. If you look at it, then this is again from the force point of view, you can show it. This is the roller support, this is a pin support whose reactions could be shown, this is a fixed support. So these are the three different supports. And if you look at it here, so these are all different kinds of supports we have over here in 2D. These are the supports which are in 2D. If you look at it, a cable, a weightless link, roller, rocker. Okay, so these are all different kinds of supports. So you can answer and take any of these two, three or four forces of 2D. But if you go, you can also define and say basically supports in 3D also. And if you look at, these are our 3D supports, which is basically a cable support surface whose reactions are this is a roller. Okay, and very important support is this one, a ball and socket joint whose reactions are this, single journal bearing whose reactions are shown here. So these are 3D supports. So you have the option to answer take either any three or four 2D supports with their you have to show their reactions is very important in order to get maximum numbers. Okay, so this question is solved in this way. Okay, but be very brief and to the point. The third term is define the term structures in rigid body mechanics, also mention its type. So if you answer this question, you can look over here, and if we go over here, and if you go here, this is the mechanical systems. Okay, so structure is defined fully over here. Okay, structural analysis in mechanics, structure is anything that can sustain external loading or exert and alter the forces. Structures are all around us, we can identify them. The structures are of three categories: the trusses, the frames, and the machines. Okay, we can define trusses, frames, and machines if we want independently. I have already explained them in our video also. So and its types is basically trusses, frames, and machines. Okay, so this is being defined here. I hope this serves the purpose. What about using a sketch defined wrench in statics? Okay, very important question. If you go here, and if you again go here, mm, and if you look, this is one of my videos that I have made, a wrench system in mechanical engineering. Okay, if you see this video, and this video is basically being placed in the playlist for statics conceptual reasoning questions, and you can watch this 5 minutes video, 6 minutes video. It can help you basically understand the concept of wrench in statics. Okay, so fully explanation, and its figure is this. These are the four figures of it, and this is the positive wrench and negative wrench if you want to draw the figures. Okay, so I hope this understands the main purpose of answering this 2 marks question. Be brief and to the point. This is very important. What about define moment of inertia, mentioning at least one of its applications? Okay, so moment of inertia, if you want to define, basically you have to basically go, and again if we go here, this is okay. So if you go this presentation that I have already made for chapter 10, and I have loaded as in my videos also, you can watch it if you want over here, which I have already defined it for you guys for the moment of inertia. And all these videos that will be for you go to frames and machines, and either if you want you can go here for the playlist and to see everything for the if you go to playlist, and you go to for the frames and machines over here. Okay, in the this is what frames and machines are. Okay, so if you look at it, you just click it up, and once you click it up, you will be getting the entire playlist for you guys. Okay, so you can see the theory of frames and machines explained to you over here. Over here you can understand all these numericals that I've made for okay, so very important. Here you can get the basic fundamental aspect of understanding of the frames and machines. Okay, so so moment of inertia, if you look at it over here, uh, again for frames and machines, and basically we have to go for this is second moment of area versus the moment of inertia. Okay, this is the full playlist for the second moment of area and moment of inertia. So if you look at it over here, we have already explained. If you look at this video, what is second moment of area, moment of inertia, and introduction, these two videos, you can basically very easily understand the concept of what second moment of area is and what moment of inertia is. Okay, from here the full explanation is defined over here. Okay, so if we go here, and again to understand that concept, okay, so this is moment of inertia. It is the ability of the body to resist angular acceleration and deceleration when the body is in rotational motion, and about an axis. It depends upon the distribution of mass within the body and its geometry. It is often used in rotational dynamics and vibration of machine elements. Its formula is Im equals to integral of r square dm. If you integrate it for integral of dm, you will get it as r square rho dv. This is the main formula for the moment of inertia, and if you want, you can also draw this picture for the further explanation of the moment of inertia, and Im equals to integral of r square dm. Make sure that moment of inertia is very important, is not second moment of area. It's totally different thing when second moment of area is being asked. Okay, so remember this thing. And the applications area in the real different fields of mechanical engineering are basically, it is being used very widely in flywheels. Hollow shafts can transmit more power. Ship's moment of inertia is made higher and pitching to encounter large waves. Higher moment of inertia is required to make mechanic more robust against vibration. So, and knowledge of moment of inertia is required to study problems in vibrational engineering. So these are the main applications from the mechanical engineering and ship engineering point of view. Okay, so this also explains, and you can write the solution from here. And what about this one? This question is very typical. Okay, what are the non-concurrent and non-parallel force systems, and draw the figures. Okay, so if you look at it over here in this explanation that I have given you, uh, I have shown many systems for you. Okay, so for non-coplanar and non-concurrent force systems, you have to basically uh, look up for this video of yours. Okay, this explains everything. Non-coplanar parallel force system. This is basically a non-coplanar uh, parallel force system, which is A. B is a non-coplanar concurrent force system explained over here, and C is basically a non-coplanar non-concurrent force system. And remember, these are all 3D systems. Okay, so you can watch this video to understand, and their explanation, definitions, characteristics is being explained over here. Okay, A, B, C explained. And for other kind of systems, for very simple 2D force systems, we have defined collinear forces as this: A, coplanar parallel forces; B, coplanar like parallel forces; C, and coplanar concurrent forces is D, and coplanar non-concurrent forces is E. Okay, so this is explained over here. And again, further explanations, if you want, for 2D 3D explained together, is this one. And this is very important, again, where 2D basic 2D equilibrium force systems are explained over here with their independent equations that sometimes can come with just the collinear lines are here, and free body diagram with their independent equations. Okay, so this is how basically you shall be solving this problem for what are non-concurrent and non-parallel force system. Define them, and also draw their respective figures that can basically be helping you over here to draw their figures. Okay, so just draw the respective figures to get the solution. So this was the explanation that I have given you, and I hope my this explanation regarding our exercise for static concept builder questions part 2 will help you in your future endeavors. Thank you very much, and you have a wonderful day. Bye.